Hello, welcome back to 40 Minesweeper variants. Yeah, we're gonna continue +8 today. Last episode we did a singular puzzle which took us more than 40 minutes, so that's cool. I guess we're gonna keep going, hopefully nothing as bad happens to us. I think 2v2a is so far the most notorious combination in the base 14 variants, so yeah, this is well, hopefully only gonna get better from here. Jeez, but okay, Liar also pretty interesting. Well, let's take a look at this puzzle. Triplet. So the easier variant, mines cannot form 3 in a row, horizontally and vertically. They can form diagonally 3 in a row though. And non-mines also cannot form 3 in a row horizontally or vertically, but they can form diagonal 3 in a rows. That's a simple one. Liar is every row and every column has exactly one liar, and a liar is a clue which is either one more or one less than its actual value. So yeah. Alright, well let's start with the simple logic first. Because of triplet, this can't be empty, this can't be non-mine, this can't be non-mine, this can't be non-mine, and this can't be non-mine. Now this one over here, suppose this was a mine, suppose this was a lie, suppose this was the truth, then the one here would cause this 3 to definitely be a lie. But suppose it was a lie, then it is just a lie. So in both cases, there is a lie in one of these two cells. And because of the liar, having only one liar in every column, the rest are not liars. So there you go. There is one mine here because it's not a lie, and this 2 is therefore complete, so that's not a mine. Well, by triplet now these can be mines, which would complete this one. This 3 is definitely telling the truth, so that's a mine. This 3 could be lying. This has to be a mine though by triplet. 4. No. This one, if it were a lie, would be a 2 because it can't be 0. If it was 0, then this column is broken. So it must be a 2. And that would make 3 correct. Otherwise, it is just a 1. And then this 3 will be wrong. It will be a 2. But I think both will work. So I don't see much. Oh, by triplet, this has to be a mine. Sorry, because of this 3 in a row. And this 4... Well, this 4 is either completed or it's not. It could be a lie though. I guess. If it were a lie, it would have to be a 5. Yeah, because it can't be 3. So if it were a lie, it would have to be a 5. And one of these would be mines. Okay. So I think one of these are mines, and nothing else in the column is a lie. And that's because if this was a lie, it's a 5. If it wasn't a lie, it's a 4, and none of those were mines. Sorry, I should really revise my notation. If it was a lie, that's an X. This 4 will have to be a 5, but it will then be a lie. If it was telling you the truth, which is denoted by a tick, then its 4 will already be completed, causing this 3 to then become a lie because it only sees 2 mines. So either this is a mine, or it causes this to be a mine. So one of these 2 are lies, and therefore everything else in the column should be the truth. Either that or it's a mine. Well, either way. This 4 is telling the truth, this 5 is telling the truth, meaning that there is exactly one mine in here. Not sure if that's useful to us. Might affect this 4 in some way. 6 being a lie is interesting. I guess say 6. Can you solve 6? Oh yeah, it's that simple. How do you put 6 in a row without causing 3 in a row? You ever played that one game where it's try to put 6 crosses in a 3x3 grid so that you don't ever get 3 in a row? Yeah, it's possible. You just put a mine here, 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 and here. So that is just spoiler your solution. And it works. So 6 in fact could be telling the truth. If it were lying though, it would have to be a 5 because it can't be a 7. A 7 would have to have a mine in all of those cells, which very clearly makes several 3 in a rows. So it's either a 5 or a 6 basically. Interesting. Not sure what else I can do. This 4 is telling the truth. But then what? There has to be a mine in here because you can't have all these be non-mines. There has to be a mine here because can't have all these be non-mines. But putting a mine there would just solve the problem, and then you could have a mine anywhere else to complete your 4. If it were empty, you could again have a mine here and a mine anywhere in here to complete your 4. So both work, I think. Which doesn't really help. If this were empty, you'd have a mine here and a mine here to complete the not break triplet. But that doesn't really tell me anything. Oh, is it a 3 and a 5? I think it might be. Because this has to be a liar. This can't be a liar. And I'm telling you it's because of the 3 and the 5. Whatever the 3 sees here, the 3 will see this plus whatever's in here. The 5 will see this plus whatever's in here. And because 5 is 2 more than 3, the 5, whatever it sees outside, must be 2 more than whatever the 3 sees outside. If both were telling the truth, this is only possible if you had 3 mines here to counter the 1 mine in the 3's range. Yeah, and that would break the triplet rule. So it is not possible for both 3 and 5 to be telling the truth. There has to be a liar somewhere. And I don't know where, but it has to be a liar somewhere, which hopefully means that none of these are mines. None of these are lies, which is in fact correct. Therefore, this is a lie. And therefore, if 3 is correct, these are both mines. Cool. Okay. Now, I say now as if I was like, I don't know what I'm doing. No, I don't. No other freebies that I can work with? I don't think so. Okay. This 4 over here, once again, has to exactly 1 mine here. But I think it could be anywhere. If that happens, then that happens, but again, nothing wrong with that. If that happens, then you'd have this, nothing wrong with that once again. Maybe the 5 does help? If the 5 had a mine here, no, if the 5 had a mine here, that wouldn't necessarily break anything yet, except the 4 will be a lie. Oh! Yeah, if this was a mine, I think that breaks. The 4 will be a lie, and 4 will then be a 5, which means that this can't be a mine, otherwise 4 will be 6, which is not how liars work. But that also makes 3 a lie, because 3 only sees 2. So this can't be a mine. Oh, okay. Cool. So this 5, which is telling the truth, must have a mine here. This 4 is complete because it's telling the truth. And by triplet, this has to be a mine. By triplet, this has to be not a mine. And then by triplet, this has to be a mine. By triplet, this has to be not a mine. And by triplet, these have to be mines. Lots of like free triplets here. This 6 now can't be 6 because we saw that 6 has only 1 solution. And that solution is broken by this cell already. So this 6 must be a lie, which must be a 5. And these can't all be mines. So there's at most 2 here. So there must be 3 here. So that these are the 3. By triplet, these and these can be mines. By triplet, that can be mine. This is probably to do with the 4 somehow. Any freebies on the board? No, I can't prove anything's a mine. This 6 must be a 5 though, which means that must be a mine. And by triplet, none of these can be mines. Oh my gosh, 2 more 6s. Well, we don't know if they're lies or not. They could both be lies actually. Actually no, they can't both be lies, because in fact if both were lies, then these will both be telling the truth, which we already know is not possible. In fact, shall we go deeper into this 3 and the 5? No, because like 3 could always be a 2, 5 could always be a 6. Actually 5 can't be a 6. In fact 5 can only be a 4. If 5 was a 4, then 3 will be correct, and then yeah, no, this is fine. Alright. I think 5 can just be a 4, or the 3 can just be a 4 as well. Both would work in like stabilizing this. Although I think none of these are mines, because whichever was the liar here has to be closer. The further you are away, the worse it gets. The further you are away, the greater the difference between mines in these 2 lines must be. But we already know that you can't be 2 more, right? So you must get closer and closer, which means that they have to get closer to each other. And because the closest you can ever get is 1 apart, then this must have 1 more mine than here. And because this is already a 2, this must be exactly 1. And so none of these are mines. Cool, okay, gotcha. This 1 is telling the truth, so this can't be a mine. 3 again can't go further away, so it can't make it a 2. In fact, it must be at least a 3. And it can't be a lie because it can't be 4. We already know that. There's no space for 4, so it must be telling the truth. which means it's a 3. This 5 is a 4. Awesome. Alright. Yeah, okay, this row must have exactly 1 lie up, so that's a lie. This 4 must therefore be a 5, so that's a mine. What else do we have? No, nothing here that can be really seen. 6 is telling the truth though, this 6. Which means that the only way to solve it is by doing this diamond pattern. And now this 6 is, it could be telling the truth still. You could have a diamond pattern look like this. But by triplet we can do a lot of things. None of these are mines. Any other triplets I can see? Not right now. Okay. 2 over here. Well, there must be at least 1 mine in here. Otherwise you have 3 in a row of non-mines. So this 2 is definitely lying. So this 6 is telling the truth, which means it must be solved like this only. 4... no, I don't see anything with the 4. This 4 is telling a lie though. Can't be anything else. This 4 is also telling a lie. This is definitely a lie as well. So we've seen all the lies. This 4 therefore can't be a 4. It can't be a 5 either because there's no space. So it must be a 3. This 2 must also be a 3 because it must be a lie. So that's a mine. By triplet you can also tell that's a mine. This 4 must be a lie, but I already sees 4, so it must see 5. By triplet, that's not a mine. And 1 mine remaining, so it's there. Cool. Alright, well this was fun. Oh, even the mines even have their own symmetrical pattern. And also, this staircase is very, very common in this in this triplet thing. You even see like in the example, you get staircases everywhere. So yeah, the staircase is a very important part of triplet. But alright, that puzzle was significantly more fun than the previous one. Next, horizontal deviation. Oh, HD. Alright, well, horizontal means that mines must have a partner horizontally. So these singular mines with no partners beside them are not allowed. And deviation. Deviation means that the number indicates the mines in the 3x3 above it instead of 3x3 around it. So you can see by hovering here, it shows you the area of effect. Okay, well, let's start with the simple logic. This can't be a mine. If it were, it would be isolated immediately. 4 here and 2 here. Yes, because there can only be 2 mines in this square, the 4 must see at least 2 more outside, so these are both mines. And because there are already 2 mines in here, there are no mines here. Ooh, 1 and 4. 1. Well, because there's 1 mine here, there's exactly 1 mine here. And whichever it is, must have a partner on the side, so you always have mines next to each other in here. Cool. Therefore, there can't be mine here, because you would have to have a mine here and that breaks this 2. So this must be a mine here and here. This mine now must have a partner. This 5 is just complete. This 6 is also complete. 4 now kind of a mine here, because if there were a mine here, this would be empty, isolating it. So that's a mine, which must now have a partner. This one is complete by that mine. And this 4, we don't know yet. This 4 is definitely complete though. This 2, no idea. This 3 is complete, okay. Did not realize that. This 2, can't really say anything because it doesn't have any control over what mines are there. Maybe this 2 and this 4 might be useful though. Maybe this 4 and this 3 more like. Not entirely true, no. I don't see it. Like, say there were a mine here for this 2, then these would both be empty. This 4 would now have to have a mine here, here, and here. Would that break anything? The 3 would be complete. Everything has a designated partner. This 4 has a mine here, but that also has a partner on its own. This 4 is complete. This can't be a mine, this can't be a mine, this can't be a mine by regular horizontal rules. But nothing out of the ordinary here. I think this all works. All stemming from the fact that this is a mine. If it wasn't a mine, then by this 4, because there's exactly 1 mine here to finish this 2, the 4 would have to have 2 mines here. And the 3 therefore kind of a mine here, because then these would be non-mines and therefore it would be isolated. And the other option was to have a mine here, which again puts mines here, here, and here, and therefore makes this a non-mine. So this is never a mine. Alright, it's a 2, that works. Is that useful though? Any mine here can always just escape out this way. Or the other way. Mines on the sides would then prevent these from being mines, because then we have no partners. But there could also be no mines on the sides if you had a 3 that looked like this. Like, this is valid. And then you could in fact have something that look like this. Okay. I mean, okay, suppose there was a mine here. It will need a partner here. And this 4 will be complete. This 4 will require a mine here, which will require a partner here. This 3 will therefore be complete. This 2 must have no mines here because then they will be isolated. This 4 requires a mine here, and this 2 will therefore be complete. But I think everything checks out. I think everything checks out. Yeah, everything checks out. Okay. What if there were a mine here? We need a partner. That doesn't really help us. It does tell us something about the 4 maybe? Not really. No. If this were a mine, then it would need a partner, which gives us some stuff to work with. This 4 is then broken. There you go. Okay. So now this can't be a mine. I think this also can't be a mine. If it were a mine, it would need to have a partner, and therefore now these are mines, which again breaks it. In fact, there must be at least 2 mines here. Oh, that's like the easiest one. Yeah, this is just regular Minesweeper. Because of the 4 here, there has to be at least 2 mines here. Even if you had a mine here and here, you would need to have at least 2 mines there, which would already complete this 4. So none of these 3 would have been mines anyway. One prevents this from being a mine, because otherwise we have no partner. 1 here implies that this now can't be a mine. And 1 here means this can't be a mine because again, no partner. Therefore, this is a mine which needs a partner. This one is a mine here which needs a partner. This one is complete. This 2 means there is exactly 1 mine here. So I don't think this can be a mine anymore. If it were a mine, then the 3 would have to have 4 mines around it. And so this can't be a mine. Nice. So there's exactly 1 mine here. The 4 would have exactly 2 mines here, and therefore there would be 1 mine here, which works. This 2 doesn't see these 2 mines down there. Okay. This 4 must have 3 mines in here. And I guess this can't be empty then, because mine here, here, and here to complete this 4 will isolate this. So this is always a mine. And I guess this also can't be empty, because mine here, here, and here to get you to 4 also isolates this mine. So that's also a mine. This now can't be mine, otherwise it will be isolated. This now can't be a mine again. Okay. Exactly 1 mine here, but I don't know where. 4 and 3. Oh, is this always empty? There is 1 mine here, therefore for the 4 there will have to be 2 mines here. For the 2 there has to be 1 mine here, and this 3 will be completed by the 1 here and the 2 here. So this is not a mine, which means that is a mine. This mine must have a partner. This can't be a mine by horizontal. This 2 requires a mine here, but they can't be here or there because they will then be isolated. So none of these are mines. This now can't be a mine by horizontal. This therefore is the mine for the 2, which does have a pair. This must be a mine for this 2, and this 4 is complete. Wow. Okay, and 6 out of 7 remaining, which means that, well, they have to be because oh my goodness, because these can't both be empty. There have to be at least 1 mine in here. But having at least 1 mine in here requires you to have 2 mines in there. And I guess I should explain why these can't both be empty. If they were both empty, then you only have 5 cells and 6 mines, which is impossible. So they must both be mines. This 2 is complete, so that's not a mine. And therefore 4 mines remaining, so those are all mines. Sweet. Okay, well, that was definitely a set of puzzles. A set of puzzles, I say. Yeah, this is definitely a puzzle as well. Alright, next. Oof. Product. Oh my gosh, 210. That's actually really big. Alright, so let's take a look at the rules here. So products are the numbers basically. Clues represent the product of the distances to the nearest two mines. So if you've seen the product video, you'll see the product video. Next, we have connected. Mines must either form a rectangular shape or be diagonally connected to other rectangular shapes. That's basically it. Okay, so let's start with root 2 first. Root 2 has to be a 1 times root 2. There's no other way to make it, and therefore must always see 1 here. This works the same for the rest of the root 2s, but we have a lot of options for each. The one over here must see 1 times 1. No other way of fixing that. And it is possible to have the mines in the root 2 position, as long as you don't have mines here and here, because that would then form a non-rectangular region. You could have something like this though, that's valid. One of these are mines. Yeah, we knew that. I was thinking like, this could technically be a mine if you had a mine here to form this 3 rectangle. Then this would happen. Okay, well, I guess since we can't do anything there, let's finally take a look at this 2 root 10. I've never seen 2 root 10 before, like in this entire game, I don't think. Except maybe in the demo, but I kind of forget what happens in the demo. So 2 root 10. 2 root 10 doesn't auto give us anything. So let's see how 2 root 10 works. 2 root 10 is... Well, we know root 10 could either be root 2 times root 5. So it could either be 2 root 2 times root 5. Or it could be root 2 times root 10. What? No, it could be 2 times root 10. I don't know. This is actually root 40, right? Yeah, it's root 40. So what other ways are there of making? What other ways are there of making this? Could it be 1 times 2 root 10? What's a possible way to make 1 times root 40? Can I even express 40 as sum of 2? Can I even express root 40 as a sum of like a Pythagorean distance? I don't think so actually. So I think that might mean that 1 is just not a thing. Oh, it could be root 2 times 2 root 5. That's a thing. Root 2 times 2 root 5. And what is 2 root 5? Let's see. 2 root 5 is root 20, which is root 16 plus 4. So 2 root 5 could be the distance of 4 plus 2 away. So mine there is a distance of 2 root 5 away, which is a pretty big range. You know, considering it covers such a big area, it would almost imply that there are no mines, you know, in any of these cells essentially, and more, which I just didn't bother to like draw out. But yeah, that also feels very unnatural, and I think 1 times root 40 is just impossible at this point. So let's not do that. Can we also eliminate the root 2s? Yes, we can. Okay. Okay, so eliminating the root 2s gives us the next possible option of 2 times root 10. Is that possible? Well, root 10 is root 3 times root of 9 plus 1. So a root 10 away could be somewhere here. This is root 10 away. But 2 times root 10 gives you here, 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 here. And anything within this circular range is not a mine. And does that work? I don't know. I don't know if this works. I think the 4 and the 2 might break. We've kind of mines here. Next best you have is 2 root 2 times root 5. But that also ignores things that are 2 away. I don't know, this might still be possible though, so let's just like take a look and see why this wouldn't be possible. 2 root 2 is either 2 times root 2 or 1 times root 8. And now 1 times root 8 is pretty hard to deal with. 4 again is either 2 times 2 or 1 times 4. Oh, I think is there any roots? 2 times 2 is just root 2 times root 2, yeah, so root 4 times root 4. So I think it's either 1 times 4 or 2 times 2. And in either case, root 2 isn't counted in there. In fact, this probably has its own coding. Oh, I guess not. But I guess if it were 2 times 2, yeah, everything in its range is already counted actually. So this 4 is either a 2 times 2 or a 1 times 4. And a 1 times 4 will look something like this. So I think anything here, these are all non-mines by default. I don't know if this is I don't know if this is greater than 4 away or not. But yeah, this is like how 1 times 4 would have to work. That surprisingly fits well with the 2 times 10. Actually it doesn't, because 2 root 10 would then be 2 times root 10. I think all root 10s are taken away already. Like there's one here, I guess, yeah, there's one here. There's one here, I guess, which could still be the root 10 area. But no, this is less than root 10, which would break this thing. Oh, so no, because then this could also be non-mine. And then this is far further away, so are you saying that it's possible for there to be mines here, here, and here to fulfill both the root 2, 10, and the 4? Yeah, those 3 mines do fulfill them, but it's just whatever's inside this range kinda has to be non-mines, which I think breaks the 2 root 2. Okay, so I'm just a bit scared of touching the 2s. I think it's valid for me to touch the 2s here though. Yeah, okay. Cool. So now this 4 has to be 2 times 2, which is just forced to be that. Okay, 2 root 2 is now 2 times root 2, because it already sees a root 2. So it can't be 1 times root 8, which means this can't be a mine. One of these are mines. This 2 times root 2, this root 2 has to be 1 times root 2, so one of these are mines. This 2 times root 2 is it could be 2 times root 2, or it could be 1 times root 8. No, but this thing is not. This thing is less than root 8 away, because root 8 away is here. So this has to be 2 times root 2. So that happens. Then this has to be a root 2 here. You know, one of these are mines. Oh, and I guess this just works. Is this... Oh, this is a 2 root 2, and this is a root 5. There you go. So that does give you 2 root 10. Okay. This can't be a mine by the root 2 here. So now one of these are mines, at least. This is now complete. This root 2 must see at 1, so it has to be there. This 2 root 2 must have a mine here. Okay. Cool. Oh, well, by connected, which is the first time I've ever seen connected, this has to escape, so it has to be a mine. And there has to be a mine here somewhere. So I don't know exactly where. This can't be a mine, because otherwise you have a non-rectangular region. Same here. And now, I guess at least one of these have to be mines. But it doesn't really help with anything. If this were a mine, then nothing much happens. Okay. If these were both... No, there has to be at least one mine here. I can't say these were both empty. There has to be at least one mine here, because you have to have 2 mines out of a distance of 1 away. This root 2... I don't know. We know one of these have to be mines, but it could definitely look like this, which gives us more options here. If this happened though, that might be a problem. Yes, in fact, yeah. If this is a mine, then none of these are mines, because you can't have another 1 here, otherwise this number would just be 1. By connected, this can't be a mine, otherwise you form a non-rectangular shape, which now isolates this set. So this can't be a mine. This must not escape through here. And now no rectangular shape, so that can't be a mine either, meaning that's a mine. This 1 must see 2 1s away, so there you go. No, this could still escape this way, or it could escape this way. Sweet. Now what? I think there has to be at least one mine here, because if there were mines in here, none of these are mines, and the only way out is here, which would form a non-rectangular shape. So there has to be mines in here, which means none of these are mines. 1, 2. 2 is either root 2 times root 2, or it's 1 times 2. Both of them look possible at the moment, I think. If this were a mine, then you'd have to form a rectangle like this. And that, no, this could still extend. And then you could do something like this, I think. Yeah, this is valid. And then you could have something like this to give you a 1 times 2. Or this, I guess. So this could extend this way. It's not entirely an issue. So yes. Okay. What about here? If this was a mine, then these have to be empty. This has to be empty. This has to be a root 2 times root 2, which means these are both empty. This has to happen, which now cannot do that. I think this looks fine. This has to go out. No, one of these are mines, but again, that's entirely possible. This has to escape. Again, that's entirely possible. So yeah, no, this is fine. This looks fine to me. Yeah. Alright. Now what? Could still be like one of these things, I guess. If this was a mine, then you'd almost basically have this. That's a very interesting shape. Because all the other 1s and root 2s away cannot actually see anything. Oh, and that isolates this. Okay, so this can't be a mine. Which means for this one, these have to both be mines. Now this can't be a mine, otherwise you make a non-rectangular shape. This has to, it doesn't have to escape. Does it have to escape? Can you escape through here? If you try to escape through here, you would have to form this rectangular shape, which cannot do that. So I don't think so. I think this has to escape through here. This, no, this still works. If this was a mine, then yeah, the same problem occurs when none of these are mines, which would isolate it. So this can't be a mine either. Could still be a 1 times root 2 though. So I don't know. So let's say this happened then. Then that has to happen. This 2 now has to be root 2 times root 2. Which, fair enough, I guess. But this has to be a mine to help you escape. What, I don't get what's going on anymore. No, this still works. This still works. What if it's the other way around, where this happens? Because you can only see 1 times root 1, or 1 times 1 distance away. But did we also not figure out that this is technically possible? This 2 could be a 1 times 2. Could also be a root 2 times root 2, I'm pretty sure. Yeah, it could still be a root 2 times root 2. Like, this is still valid, I think. Yeah, everything still escapes. Does it start to mingle with this number? I don't know if it starts to mingle with that number. It's a bit weird. Definitely a little bit weird. If this was a mine, then this has to happen. If this is a mine, that breaks. If this is a mine, this is not a mine because no non-rectangulars. This can't be a mine because then this root 2 will break. And that would isolate this, unless this can go through here. But we know it can't, because we know that, I already knew that if it had to, it would form a rectangle here which would break. So yeah, no, this can't be a mine. Which means this must escape through here. Which means it must escape through here. If this were to happen, then this root 2 requires a mine here which would break. So I think this also can't be a mine, which means this must escape through here. This root 2 requires a mine here, and this now can't have a mine there. This now can't go out, otherwise you form a non-rectangular shape. Yeah, okay. So now this can't be a 1 times 2 because it already sees a root 2, so it must be a root 2 times root 2. That can't be a mine. Yeah, okay, that works. if this could both still work? I think both could still work. If this happened, yeah, both could still work. And then this could still be a mine, yeah. Maybe this can't be empty though, because if this was empty, you either have empty here, you either have empty here or empty here. These can't both be mines. So you either have empty here, which if this was empty would break, or you would have an empty here, which if this was empty, requires this to be a mine, requires this to be empty, and requires a break. So this can't be empty, it has to be a mine. Cool. That can't be mine, otherwise it would be non-rectangular. Something about escaping. What is going on? Why is this making some weird Aleph Null type looking digit? What? Okay, cool. It doesn't look that bad actually, it looks pretty nice. Alright, hold on. Let's see if my brain... No. This root 2 still doesn't... This root 2 still refuses to help. Like both legitimately still work, right? Yeah, it's like it's almost like it's forming its own loop kind of thing. Is it about remaining mines? If these were both mines, does that break? This can't be mine, this can't be mine. This could still be mine. This can't be mine. These can't all be mine, but you could have at least 2 more here. Could have mine here. Oh, wow. Wow, and that I think breaks. Yeah, because you wouldn't have enough space to put in 8 mines. All of these have to be mines. Or at least 4 out of 5 of these have to be mines. And in a lot of cases, would just break the rectangular rule. So I think it's not possible for these to both be mines. Which means this is always a mine. Or I guess more correctly, if this was a mine, we did realize eventually that... no, actually we didn't. But I do know that this has to be a mine. Which, now what? I also think these can't both be empty. Because if this was both empty, then the similar situation occurs where you won't have enough space for that many mines. So this forms its own rectangle as well. I think this does the exact same thing. Because if it didn't form its own rectangle, could you actually fit that many things in? Yeah, 5 remaining. I mean, I guess we can start by doing this not a mine. Oh, this has to be a mine then. Now none of these can be mines because they can't form non-rectangular shapes. This has to escape somehow, so that has to be a mine. Now 3 mines remaining. If this was a mine, yeah, that doesn't work because you'd have to have a mine here and a here, which would break. So the mine must be the 2x3 pattern. There you go. Okay, well, this was definitely a puzzle. And I think the shape has changed. There's no longer some Aleph Null type. No, I mean, it still looks like some weird K0 type digit. But I'm just seeing things. Alright, well, this is probably enough Minesweeper for today. Oh, my brain is fried. I don't know how long I've been playing this. But yeah, very soon, very soon, we'll reach the end. Oh, more encrypted. Alright, we'll do that next time. Yeah, but until then, hope you enjoyed this video. I'll see you guys next time. Bye bye.